All right, let's take a journey. We're going to the absolute edge of our solar system, to a place so vast and so distant we can't even see it. A ghostly halo of ice that marks the true final frontier. Today, we're diving into the Oort Cloud.
That's a pretty powerful idea, isn't it? The Great Wall between our home and the rest of the galaxy. And our only clues that it even exists are the mysterious visitors it sends our way.
I mean, think about it. When we see a spectacular long-period comet like Hale-Bopp or Neowise just blazing across our night sky, where does it actually come from? Well, these aren't just random visitors. They are messengers sent on million-year journeys from a vast, invisible reservoir at the edge of everything we know. So what exactly is this place? Well, what's crucial to understand is that the Oort Cloud is still theoretical, but it's this idea of a giant spherical shell of icy objects. If you can, picture the planets and the Kuiper Belt as a flat disk, kind of like a vinyl record. The Oort Cloud would be an enormous soap bubble enclosing the whole thing. It's the sun's ghostly halo. Now, when I say enormous, that word doesn't even begin to cover it. The distances we're talking about are so mind-bending that we're going to need an analogy to even start to wrap our heads around it. So let's try one out. Okay, imagine our sun, the center of our entire world, is shrunk down to the size of just a single grain of sand. On this scale, Earth, our home, would be just 1 inch away from that grain of sand. The farthest planet, Neptune, would be about 2 feet away. And the Kuiper Belt, where Pluto hangs out, that would end at around 3 feet. See, it's all pretty compact, right? A little neighborhood. Well, on that same scale, the inner edge of the Oort Cloud, it wouldn't even be in the same room. It would start about 130 feet away. That is a huge jump across a vast empty space. But believe it or not, that's just the beginning. And the outer edge? That would be over a mile away from our tiny grain of sand. That is the true scale of our solar system. A tiny, familiar core of planets surrounded by an impossibly vast sphere of ice. And if you want to translate that scale into time, think about Voyager 1. It's the fastest, most distant object humanity has ever launched. For it to reach just the inner edge of the Oort Cloud, that's going to take 300 years. And to cross it completely, about 30,000 years. Just wow. So the big question is, how did this colossal structure even get there? See, the objects in the Oort Cloud weren't born out there in the dark. They are exiles, castaways from the chaotic birth of the solar system itself. So the story goes something like this. About 4.5 billion years ago, as the planets were forming, the giants like Jupiter and Saturn started migrating and shifting around, which caused total gravitational chaos. They basically acted like these cosmic slingshots, flinging trillions of icy bodies out of the inner solar system. These objects couldn't quite escape the sun's gravity, so they were captured at the edge. And then, over billions of years, the gentle tug of our galaxy and the occasional passing star sculpted all those random orbits into the giant sphere we theorize today. So, this cloud isn't just a uniform mass. It's actually a dynamic region, the great nursery where long-period comets are born. It even has a distinct anatomy. The Oort Cloud is really 2 parts. First, there's the inner cloud, sometimes called the Hills Cloud, which is shaped more like a thick donut or disk. You can think of this as a dense reserve of comets. Then, further out, you have the outer Oort Cloud, which is that vast, perfect sphere we usually think of. The objects way out here are so loosely bound to the sun that they are really easily disturbed. And that's the crucial point. Objects in the Oort Cloud don't just decide to visit us. They need a nudge. And this nudge can come from the tidal forces of the Milky Way itself, or maybe the gravity of a star passing nearby, or even our whole solar system just moving through a dense cloud of interstellar gas. Any one of these tiny disturbances can disrupt a comet's stable orbit and send it on that long, slow fall toward the sun. So, in a way, the Oort Cloud acts as our solar system's first line of defense. It's the boundary where our sun's influence, the solar wind, finally meets the interstellar winds of the galaxy. It really marks the edge of our home turf. But here's the paradox. While it's a shield, it's also the source of some of the most potentially hazardous objects out there. These long-period comets come screaming into the inner solar system at incredible speeds, which makes them really, really difficult to predict and track. So we have this impossibly distant, invisible cloud of ice at the absolute edge of space. Why should we care?
Because, and this is the amazing part, the story of the Oort Cloud is deeply connected to the story of us.
Okay, so really, why does this ancient frozen region matter so much?
Because each and every one of those trillions of icy bodies is a time capsule. I mean, they are deep frozen samples from 4.5 billion years ago, perfectly preserving the primordial water ice and the ancient organic molecules that were around when the planets first formed. It's actually believed that comets just like these, knocked from the Oort cloud, delivered the essential building blocks of life to a young Earth billions of years ago.
So every comet we see is a little piece of our own history, right? A messenger from our solar system's birth. Or is it? Well, get ready for this. Recent theories suggest that as many as 90% of the comets in our Oort cloud might not be from our solar system at all. This is just one of the most incredible ideas in modern astronomy. Our sun was born in a dense cluster with lots of other stars. And in that crowded stellar nursery, it's believed our sun's gravity was strong enough to literally steal comets from its siblings. This means the Oort cloud isn't just our history. It could be a vast library of material from other long-lost solar systems. Which leaves us with a final, fascinating question. The next time you look up and see that faint, beautiful streak of a comet across the night sky, are you looking at a pristine relic from the birth of our own world? Or are you maybe witnessing a ghost, a messenger carrying the stardust of a completely different alien solar system?